Hi, this is Jacob Hawkins, and I'm presenting on our 7th Interactive Advanced Concept presentation. This week we are going to be demonstrating quote-unquote balloon geometry. So we're obviously not really going to be talking about the geometry of balloons. We're going to be talking about something called electron domain geometry. So before we dive into that, just to cover a few key terms. So electron domain geometry is the arrangement of electron domains, which are either bonds or lone pairs, around a central atom. And an electron domain is a lone pair of electrons or bonds, regardless of whether the bond is a single, double, or triple. So electron domain geometries will include linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral geometries. And we'll kind of demonstrate those by making balloon models and using those to kind of take a look at what those structures would look like, and also give some examples throughout the video, of what kinds of molecules could be represented by those geometries. All right, so the first electron domain geometry we can talk about is the linear geometry, which I have modeled here, this balloon structure. So in this type of geometry, we have two electron domains represented by these two balloons. And then in the center, this little knot here will represent like the central atom of the molecule. Now that's going to be the basic setup for all of the models that I show you for this presentation. Balloons will always represent electron domains, and then we're going to assume that in the middle there's some kind of central atom that the domains are centered around. So for this particular type of domain, there are 0 lone pairs. So that means that the molecule would be an AB2 molecule, where you have BB and then A in the middle. And an example of this would be CO2, carbon dioxide. The next type of geometry that we're going to talk about is the trigonal planar geometry. Now you see here with this model, we have 3 electron domains. And with this type of geometry, there can be either no lone pairs or there can be up to 1 lone pair. So that means that this type of molecule would either be an AB2 molecule, which would be, 2 Bs plus a lone pair, or it could be an AB3 type molecule. So examples of those would be sulfur dioxide. That would be a trigonal planar geometry that has a lone pair, or it could be boron trifluoride, which has all electron domains, on this structure are represented by actual atoms of a specific kind of element. Next up is the tetrahedral geometry. So let's see if we can see this clearly. With every balloon I add, I need to kind of pull myself out farther and farther. So you see here that we have 4 electron domains, and that means that we can have either 0, 1, or 2 electron pairs. And the types of molecules that would fit into this category would be either AB2, AB3, or AB4. Now, examples of this would include ammonia, NH3, so that would have 1 lone pair. Also, H2O would be an example of this. That would have 2 lone pairs, or methane, which is CH4, and that would obviously have no lone pairs. All right, next we have our trigonal bipyramidal geometry. So we've got this structure here. So you see we have a total of 5 domains here. So we have the 3 here, and then 1 on top and 1 on bottom. So with this type of geometry, like I said, there are 5 domains, so that means that there can be either 0, 1, 2, or 3 lone pairs. Examples, actually, let's start with the molecules first. So the molecules that would fit into this category would be AB2 type molecules, AB3, AB4, AB5. And then examples of this would be sulfur tetrafluoride, which would have 1 lone pair, chlorine trifluoride, which would have 2 lone pairs, iodine difluoride, which would have 3 lone pairs, or phosphorus pentafluoride, which would have no lone pairs. And last but not least, we have the octahedral geometry. So you can see here that we have a total of 6 electron domains represented by the 6 balloons. Now with this type of geometry, there can be 0, 1, 2, or 4 lone pairs in it. So that means that the molecule could be AB2, AB4, AB5, or AB6. Examples of this would include bromine pentafluoride, which would have 1 lone pair, xenon tetrafluoride, which would have 2 lone pairs, xenon difluoride, which would be 4 lone pairs, or sulfur hexafluoride, which have no lone pairs at all.